Hi everyone. Today I'm gonna to show a simulation of a robot navigating in a 2D map using the bug zero algorithm. In this simulation, the robot starts a position 10 and 10 and move to the goal at a position 90, 80. The environment contains obstacles, so a black area on the map, and the robot can detect obstacles right in the front of. Argue explain how the robot move, how it reacts to the obstacle, and argue visualize the path it takes from the start to the goal. Now, uh, we starting the coding the bug zero algorithm. Okay. I coding by Jupyter, uh, or can you code by the Python maybe? Uh, True. The firstly, I import library and set up the library and set up the start position and goal position. And the bug zero algorithm logic. Uh, Here, I define the function bug zero slash navigation. It takes three inputs: the map image path, the start position, and the goal position. The purpose of this function is to simulate robot navigation using the bug zero algorithm. First, I load the image and convert it to the grayscale. Then I convert it into a number array so I can process its a grid. After that, I apply thresholding. Pixel greater than 197 become free spray, and and other become obstacle. So now I have a pyramid map where a railroad division obstacle and through 155 represents the free spray. Here, I initialize the robot's current position and the goal position. I create a new score path to store the robot trajectory. The robot starts in the goal seeking the most. I also define the step size and the maximum number of iterations to be an infinite loop. In here, I define direction for word following. There are the S possible movement direction. They present the neighboring sound around the robot. I use them during the word following to search for a free direction. Okay, uh, I want to explain more detail for the for this. Can you see? Okay. Okay, yeah, it's possible. One, two, three. Okay, around the robot. I want to robot the turn right. The robot try to move into the neighboring cell in the clockwise order. And in action, I want to robot to turn right, turn left. Uh, uh, I cause for the robot try to neighboring cell in counter clockwise order. Okay, return the cross. Okay, I has a main loop. The main loop of our algorithm I run until the robot reach the goal or the maximum number of iteration. Okay, here I check if the robot is close enough to the goal. If the distance is smaller than the step size, I consider the goal reaches and stop the loop. In scholastic mode, the robot calculate the direction vector towards the goal, then it normalize it to get a unit vector. Finally, it move one step in that direction. Before moving, the robot checks if the next position is an obstacle. It just is the sweep to where follow most. Otherwise, it updates its position and continue moving towards the wall. Even during the wall following, the robot keeps checking if the direct path to the goal is clear. If the next step towards the goal is free, it switches back to the goal seek most. If the goal path is still blocked, the robots that were following it check neighboring cells in clockwise order. The first three directions farthest will be selected as the next move. This approximates the right-hand rule. Yeah, the finally is a trapped condition. If the no free neighboring cell is farthest, the robot is trapped and the algorithm the stop. And finally, I returned the full trajectory of the robot and the processor Pyris match. And finally, I run the course to execution and the visualize the map. Okay, then you run, run, and run. Okay, can you see the red line in robot bar, and the green in the start, and the blue in the goal? Can you see? And the following the power is the obstacle. When you see uh line, the obstacle, and the line, the clear the obstacle, can the robot and the toward on the goal, and uh, continue the robot the trick the goal. In summary, this implementation follows the basic idea of bug railroad: moves directly towards the goal, switch toward following when hitting an obstacle, and return to the seeking when the path becomes clear. Although simple, this algorithm demonstrates reactive navigation behavior. Thank you for watching, and see you in the next video. If you have a question, can you comment under the video? I give the answer soon. Thank you.